Welcome to the world of compressed air-driven vacuum venturi pumps, also known as PIAB pumps. These pumps, connected to a proper compressed air source, can provide vacuum down to 11 torr. When used properly, these pumps can save you time and energy due to reduced air consumption. They can save you maintenance on your compressors and no water usage. The pumps themselves have no moving mechanical parts and are essentially maintenance-free. They do not have the issues associated with the central vacuum system and are a convenient point-of-use source of lab vacuum. When combined with the optional VacuStat, the user can maximize energy savings and solvent reclamation. The proper setting of the VacuStat control, along with careful attention to assure leak-free connections, will substantially reduce energy use and reduce solvent release into the environment. Your PIAB pump is shipped as one unit with all of the parts necessary to connect to the compressed air turret in your lab. The VacuStat, the necessary component required to control the vacuum, is shipped separately if ordered. The contents of your PIAB pump box are as follows. The accessories box, which contains tubing, fittings to attach to the body of the pump body, as well as a connection diagram and a parts list and a silencer. The PIAB body itself is fitted with a number of different connections, each numbered 1 through 3. Connections numbered 1 are located on the bottom and on the side of the pump. These connections are for compressed air inlet, and you may choose which inlet to use. The compressed air must be delivered to the pump at a minimum of 87 pounds per square inch at the inlet and a standard 5.5 cubic feet of air per minute. Please note that this air must be clean and oil-free to ensure long-term satisfaction with your pump. Normally, your pump is shipped with an air inlet valve attached to the inlet numbered 1 on the bottom of the pump. Connections numbered 2 are located with one on the bottom and a smaller one with a screw inserted on the top. The bottom connection is the vacuum inlet, and this is the inlet with which you will connect to your application. The smaller vacuum inlet on the top allows you to connect a small line to the VacuStat to control the vacuum. Connections numbered 3 are there to provide the user with 3 orientations for the pump exhaust, one each on the bottom, side, and top. Additionally, there are 2 retort stand connections, and these are located one on the top and one on the side. The vacuum pump is also fitted with 2 gauges. The first one is for the compressed air inlet, which measures the inlet air pressure. This gauge is scaled from 0 to 10 bar, with 6 being the correct operating pressure of 87 psi. The second is a vacuum gauge, which will indicate your approximate vacuum level. The VacuStat, which allows you to control vacuum level, is in the separate accessory box. In this box you will find some connection tubing, the VacuStat itself, some rubber O-rings, and the connectors with which to be able to connect this device up to the vacuum pump body, as well as a connection diagram and a parts list. Now we will show you how to connect the pump and all of the fittings. It is assumed that you will be using your pump with the VacuStat attached. First, remove the screw located in port 2 on the top of the pump. Thread the small tubing through the body of the pump. Install the small hose barb supplied with the VacuStat into port 2, ensuring that you have placed a rubber O-ring on the barb before installing. Cut the hose as required to fit and install the hose on the hose barb ends. Likewise, install the small hose barb onto the VacuStat, once again ensuring that you have placed a rubber O-ring on the barb. Note the arrow indicating the direction of flow on the VacuStat, and then connect the VacuStat to the air inlet valve. Using a 2 to 3 inch length of the larger diameter hose supplied with the pump body, connect this between the air inlet valve and the VacuStat, removing any protective plugs. At this point, you can connect the other side of the vacuostat to your compressed air turret. With the exhaust, it is important to point out that you have two methods of exhausting. One is with the supplied silencer. Silencers should be used only with aqueous solutions in the open environment, or if the PIAB pump is being installed in the fume hood and the exhaust is being emitted directly into that airstream. The other is with a connector that allows you to connect to a hose barb so that you can run the exhaust into your chemical exhaust system in your laboratory. Now that all of the fittings have been installed, we are ready to adjust the vacuum. The process of setting the desired vacuum level is quite simple. By sealing the vacuum line, rotate the knob on the vacuostat. Note the plus and the minus directions indicated on the knob. Rotating the knob in the plus direction indicates a stronger vacuum, while rotating in the minus direction indicates a weaker vacuum. This may take a few tries, but once you get the idea, it becomes easier to operate. Initially, you will hear a continuous flow of air through the pump. Rotate the knob in the plus or minus directions until you hear the airflow stop. Note where on the vacuum gauge this occurred. If, say, it happened at about minus 500 millimeters of mercury, but you desired minus 600 millimeters of mercury, rotate the knob in the plus direction. You will hear a short burst of airflow through the pump and then stop. Note the vacuum gauge setting. Adjust as required until your desired vacuum level is achieved. Now that we know how to set up our vacuum pump, let's look at some real examples of how to apply this technology in our lab. We will use a standard rotary evaporator experiment and a standard vacuum filtration experiment. For the rotary evaporator operation, it is important to know what level of vacuum should be used with each solvent. The University of Ottawa has compiled this data for us, and it shows that methanol should be used at about minus 550 millimeters of mercury, with a water bath at about 40 degrees Celsius. Connect the vacuum pump to the rotary evaporator. Adjust the vacuum to the required level. Notice that the pump, in normal operation with no leaks, requires virtually no air to maintain the required level. In fact, the almost 20 minutes required to conduct the operation of drawing off 200 milliliters of methanol, your pump should turn on only 3 or 4 times. Note also that at the end of this operation, the reclaimed methanol will approach 98%. Another common lab operation is vacuum filtration. For this operation, connect your pump through a trap to a vacuum filtration flask. There is no need to set the vacuostat as you are now effectively evacuating from the atmosphere. Maintenance on your PIAB pump is minimal. The only replaceable parts are the seals that are installed on your pump. Normally, you will have your pump shipped with CalRes seals, which should require very infrequent replacing due to chemical deterioration. Viton can only be used with certain solvents, and EPDM should only be used with aqueous solutions. It is also recommended that you use a filter or trap to ensure that foreign material does not directly enter the pump body itself. Your check valve may require periodic cleaning depending on the condition of your compressed air source. This may be as simple cleaning with alcohol. Ensure that there is no debris under the flaps to prevent the valve from maintaining a good seal. It is more likely that the flap valves on the vacuum side of the pump will become contaminated, and these need to be cleaned as well. The use of an inline filter and trap will significantly reduce maintenance on these parts. We hope that this explains the basic operation of your pump. Used properly, your pump will deliver solid vacuum for virtually all of your lab operations. Engineering studies, field testing, and feedback from people in the lab have shown PIAB lab vac technology to be a more reliable, efficient, and environmentally friendly way of producing vacuum in the laboratory than traditional methods.